This lecture is on solubilities. Solubility product constants are written for slightly soluble salts in aqueous solution. The KSP expression for PbCl2 is the product of lead-2 ion concentration and chloride ions concentration squared. If the solubility product constant value is 1.7 times 10 minus 5, the molar solubility is 1.6 times 10 to the minus 2 molar. The common ion effect states that by the addition of an anion of a slightly soluble salt decreases its solubility. In this example, calcium fluoride dissociates to form calcium ion and 2 fluoride ions. If one adds more of either ion, the system will shift left to form more precipitation of calcium fluoride, and as a result, the molar solubility decreases. Question 1 is, what is the molar solubility of PbCl2 in 0.10 molar sodium chloride? The solubility product constant value is 1.7 times 10 to the minus 5. Some slightly soluble salts are metal hydroxides, and this is the general rule of thumb. The solubility of slightly soluble salts containing strong basic anions lead to an increase in H+'s concentration, a decrease in pH, and an increase in solubility. Salts containing weak basic anions is unaffected by any pH changes. Here's an illustration showing these changes. If you add an acid to PbF2, more salt will dissociate to form lead-2 and fluorides, since F- is a strong conjugate base from weak acid HF. If you add acid to PbI2, since I- is a weak conjugate base of a strong acid HI, no change will be observed. Example 1 is, will nickel 2 hydroxide be more soluble in acidic solution? Support your answer with equations and detailed explanations. Since hydroxide ion is a strong conjugate base from a weak acid water, nickel 2 hydroxide in 2 moles of acid or hydronium ion forms nickel 2 ion and 4 moles of water. Example 2 is, will silver chloride be more soluble in acidic solution? Support your answer with equations and detailed explanations. Unfortunately, chloride ion is a weak conjugate base of a strong acid, hydrochloric acid. So when silver chloride mixes with hydronium ion, no reaction occurs. Question 2 is, which of the following substances are more soluble in acidic solution than in basic solution? A, BaCO3, B, PbCl2, C, Ag2CO3. Many slightly soluble compounds can be dissolved by the aid of another aqueous solution in the formation of a complex ion which is soluble in water. One example is CuSO4 in concentrated ammonia forms A, a precipitate, and B, a complex ion. This illustration shows AgCl has low solubility in water, but high solubility when combined with ammonia. To demonstrate that an insoluble compound is soluble in something other than water, we will look at copper 2 sulfate in first limited ammonia. Copper 2 sulfate dissociates to form copper 2 ions and sulfate ions, and ammonia forms some amount of hydroxide ions. When combined, copper 2 hydroxide is produced, which is insoluble in water. However, if you add excess ammonia, tetraamine copper 2 ion, or CuNH3 2+ ions is produced, along with 2 hydroxide ions. To show how one can find the overall equilibrium constant value involving a complex ion and an insoluble compound, one first writes the solubility product constant expression and its value, followed by its formation of the complex ion and its value, add the overall reactions, and multiply the solubility constant value and the formation constant value to give an overall equilibrium constant value to be used for analysis on the solubility of the insoluble ionic compound with a substance in aqueous solution besides pure water. In this case, the overall equilibrium constant value when copper 2 hydroxide mixes with ammonia in forming tetraamine copper 2 ion is 2.4 times 10 to the minus 7. Question 3 is, what is the molar solubility of copper 2 hydroxide in 2 molar ammonia? For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.